Hello and welcome back to our channel Learn with Harshit. I'm your instructor Harshit and I'm hoping that you guys are absolutely fine and doing well for your examination. And if you are here for the first time, then please do like, comment, share and subscribe to my channel so that you will never miss an update for upcoming future and stay connected to my channel for any further lectures and videos. Now, our today's topic is to learn trick for the constant type problems, or our today's goal is to learn trick to solve constant type problem in physics. The constant type problem in physics means the problem regarding to the pulleys in which you have to find the tension, acceleration, acting forces on the masses, or sometimes you have to find the mass of the body as well. So after watching this video, until you are able to solve these type of question in very short period of time. Now, before our explaining anything else, let's directly coming to our topic. So, our topic is trick for constant type problem. Before going to the trick, I am going to explain you what exactly is constraint supposed to be. So, this constraint mean? So, the constraint is the restriction on the motion, position, or both motion and position of an object are called constraint. It means suppose a body is in motion, so any restriction which occurs in a body and tends to change the body's motion, position, or both position and motion of a body are called constraint. Constraints are typically arises from the environmental or external forces acting on the system. Suppose you have seen a system, and due to the environment or external forces like frictions, or you can say gravitational forces, the body have changes their motion and position. So these type of things are called constraint. To better understand the constraint, let's look an example. Suppose you are in a car and driving your car with a constant velocity v1 on a straight path or in along x direction. Now, at some point when you drive a car, you found that there will be a mountain you have to climb to reach your destiny. So, what should you do to climb the mountain? To climb the mountain, you simply increase your velocity v1 so that you have to climb the mountain, or you can also change your position from x to midway between x or y axis so that you can climb the mountain successfully and go to your destiny. So one thing that I want to ask you from, why should you increase your velocity or change your motion and change your position? You have to change your motion and position just because this mountain will come, so that the gravitational forces, that is the external forces in our system, have to increases, and due to this you have to also increase your velocity and change the position to climb the mountain successfully. So we can say that in our case, this mountain will be the environmental constant, and the external forces acting in the body is supposed to be the gravitation. That is simple. So I'm hoping that you understand what constant is. Now in our case, the constant is this pulley. So this pulley and this rope, because of this pulley and this rope, the two masses m1 and m2 have different acceleration a1 and e2, as well as in different tension t1 and t2. So due to this pulley and this rope, the two masses m1 and m2 have different acceleration, different tensions, and different, you can say, weight acting on this body. So due to this pulley and rope, these factors will come. So we can say that this pulley is constant in our case. Now I'm hoping that you understand what constant is. So I'm going to the trick. What does the trick say? Trick for constant type problem. The trick for constant type problem says tension T is inversely proportional to the 1 upon acceleration, where T is the tension and A is the acceleration. So that if the inversely proportionality sign gone, we can also write it as T1 times of A1 is equal to T2 times of A2, where T1 and T2 are the tensions in the strings connected to the block of masses m1 and m2 having accelerations a1 and a2. So suppose you have a figure like that, and in which you have two masses m1 and m2 with an m1 have tension t1 and m2 have tension t2. So that m1, so I am supposing that m1 have acceleration a1 and m2 have acceleration a2. So it is pretty much clear that T1 times of A1 is equal to T2 times A2, where T1 is the tension connected to the string M1 and T2 is the tension connected to the string M2, and A1 is the acceleration of block M1 and A2 is the acceleration of block M2. So I hoping that you understand why T1 A1 is equal to T2 A2, because tension T is inversely proportional to acceleration A. So this is the trick for the constant type problem, which is T1 A1 is equal to T2 A2. Now coming to the next slide, before going to the question, I am going to explain you some points that you have to remember, or you can say memorize in your mind, so that you can solve any police question easily. First point is, in case of massless and frictionless pulley and an inextensible rope, the tension in the rope on both sides of the pulley will be the same. So So suppose you have an Atwood machine system like that, and in the question it is given that these pulleys are massless and frictionless as well. These rope are inextensible. So in that case, if suppose the tension on the one side of the string is T, then another side of the string tension also will be the T, because this pulley is massless and frictionless, so that when this mass will revolve, when this mass will go down, or you can say up, then no friction force will acting on the rope, due to which the tension will on both sides of the rope will be same. Now point number 2 says that the tension in the ropes connected to the another pulley in cases of massless and frictionless pulley and an inextensible rope is sum of the tension on both ropes. So this will say, suppose this second pulley is, as we all can see clearly, this second pulley is connected to the this first pulley. So someone asked us what is the tension of supposed to be in this string, that is the string of second pulley. So it is the sum of the tension connected, it is the sum of the tension of the first pulley, because second pulley is connected to the first pulley. So the tension in the second pulley will be T plus T, which is equal to 2T. And if this is 2T, if the left side string is 2T, then side string also be 2T, because this pulley is supposed to be massless and frictionless, and then this rope is inextensible. Similarly, what is the tension of this big pulley? This will be the sum of another pulley, sum of the pulley which is connected to them. So 2T plus 2T, which is equal to 4T. So this tension, this string tension will be 4T. And if this pulley is also supposed to be massless and frictionless, so what is the tension on the right string? It will be 40. I hope that it is clear to you that what the 2 points say. The 2 points says in case of massless and frictionless pulley and extensible rope, the tension on in the rope on both sides of the pulley will be the same. So if tension on the one side will be T, the another side will be also T, because this is the same rope and traveling on the same pulley, so that no tension changes. Similarly, it is if the you have to find the tension on the second pulley, or you can say different pulleys connected in a pulley system. So what you can do, you have to simply calculate or add the previous police tension, so you have to get the new police tension, because in this case we can you guys clearly see the tension in the second pulley is the sum of the first police tension, which is T plus T 2T. So if left side will be 2T, then right side also be 2T. Similarly goes for a big one, which is 2T plus 2T 40. So it's left side tension will be 40 and right side tension become also 40. Now hope it is clear to you. Now coming to an example to show our trick more clearly and more beneficially. Now here is the example. Which of the following relations between acceleration of block is correct? So here is the block M1 and M2, and M1 have an acceleration A1 and M2 have the acceleration A2. So the question says which of the following relations between the acceleration of a block is correct? So you have to find a relation between A1 and A2. It will be A1 is equal to 7 times of AT. It will be A1 is equal to 2 times of A2. It will be A2 is equal to 7 times of A1, or it will be A2 is equal to A1. So now let's dive to the solution and see what is the relation between A1 and A2 and how to find it using the trick. Now, first of all, I'm going to recall you what the trick says. The trick says tension T is inversely proportional to the acceleration, so that T1A1 is equal to T2A2, where T1 is the tension found in the block connected to the string M1, and T2 is the tension on the string connected to the M2, and A1 is the acceleration of block M1 and A2 is the acceleration of block M2. Now it is clear that now how to find the total tension on the block. The total tension on the block is M1 is as I so clearly how you get the tension, it is T plus it is TT, so it will come 2T, it will come 2T plus 2T, so it will become 4T. So you have to find the tension on the string connected to the masses easily. Now the total tension, how to find the total tension? You have to see what is the total tension on the block M1. It will be 40 plus 2T plus 2, which is equal to 40 plus 2T plus T, which is equal to 70. Similarly, what is the total tension on block M2? Since you can see M2 is connected to only one string and which have a tension T, so the total tension on the block M2 is T. Now what we do, we can use our trick. Trick is says T1A1 is equal to T2A2. Now we have to replace the value of T1 with 70. As you can see, we can find the value of connected to the block M1, which is equal to 40 plus 2T plus T, which is equal to 70. So replacing the value of T1 as 70 and replacing the value of T2 as T, because you can see the string connected to the block M2 have tension T. So I am replacing these value and getting that 7 times of TA1 is equal to TA2. Now cancelling the T, we got our answer 7A1 is equal to 7A2. So you find the relation between acceleration so easily by just using the trick T1A1 is equal to T2A2, and by calculating the tensions on the strings you have got your answer. So let's see the question. Which of the following relation between acceleration block is correct? So which is the correct option? I am supposing that answer C will be the correct, which is equal to A2 is equal to 7A1. So we got our answer in very short period of time. So this is the advantage of using trick. Now let's come to another trick question. Here the question says find the acceleration of block A as shown in the figure. So here you got a figure and you have to find the acceleration of the block A. So before going to our trick, first what we can do, we have to calculate the tensions in these strings so we can use our trick. Otherwise we have not use our, you cannot able to use our trick. So you to use our trick we have to first calculate the tension. So without doing anything, first of all you guys have to calculate the tension. Now let's go to start doing the tension. Now let's start the solution and finding. First of all I'm going to find the tension in these strings so our task will become easier. Now why should I use this arrow upward? Because as we all know the tensions in the strings will be toward the fixed point. So here in this case so here in the string connects to the block P, the tensions is supposed to be going upward because of this fixed pulley. And in this pulley this the fixed roof is the roof is fixed, so the tension direction will be this upward, and in this upward, and this upward. So here is the direction of the tensions. Now since you can see clearly this rope that is connected to the block A have similar rope all over the pulley. So if the tension in the in this rope is T1, so that the tension on this side will also T1 and this side will also T1. And you can see the block B have different rope. So I'm supposing that the block B have a tension T2 and block A have a tension T1. And as I explained you previously, that why should, if this T1, then this also become T1 and this also become T1, because of this pulley is frictionless, massless, and this rope is inextensible. So due to this tension will be the same all over the point, and this T2 this tension, this string tension have different because this rope is different. So this will have different tension. Now I'm also one thing I have to clear, that you have to choose the direction of acceleration as you want it. If I am letting that block B will get downward and block B will get upward, and I'm also letting that block B have acceleration A2 and block B have acceleration A1, so that I can use this in my trick. Now what is the T2? T2 is nothing but the sum of tensions. I saw you earlier that the strings, the string pulleys which is connected to the another pulley have the sum of the total tension. So T2 is what? T1 plus T1, which is equal to 2T1. Or you can say T2A2 is equal to T1A1 from our trick. So replacing the value of T2 here, we got what? 2 times of T1A2 is equal to T1A1. After cancelling T1, you got in the relation between acceleration as A1 is equal to 2A2. So it's done? No. They ask us what is the acceleration of A. So this is not done yet. You have to find the acceleration of block A. Now, to find the acceleration, this is very clear. You have to use free body diagram of block A and block D. So for you guys, I am done. I have provided you the free body diagram. Here is the free body diagram of blocks B. Here you can see the free body diagram of block B that have mass 1 kg, where tension T2 acting upward, having their weight 1g downward, and the direction of acceleration A2 is also downward. And here is the block A, where you can see the block A have mass 2 kg, where tension acts upward and weight downward, and the direction of acceleration is upward. So this is the free body diagram. Now we can use this free body diagram to find the acceleration of block. Now from the free body diagram of block P, what you get? You get 1g minus 2t2 is equal to 1 times of a2. Because the direction of acceleration is downward, so 1g is positive, the weight direction is positive, and the tension direction is negative. So 1g minus t2 is equal to ma, where m is the mass of block B, so 1 times of, and a is the acceleration, so 1 into a2. Here we got the equations for the block B. Now substituting the value of t2 as 2t1, we got 1g minus 2t1 is equal to a1 by 2 because a2 is equal to a1. So here you can see I substitute the value of t2 as 2t1 and substitute the value of a2 as a1 by 2 by cross multiply the these. So I got the a2 as a1 by 2 and we got our equation 1 as 1g minus 2t1 is equal to a1 by 2. Now coming to the second equation, you have seen block A. Block A have mass 2 kg in which the tension T1 act upward and the weight downward. Direction of escalation is upward. So it will come T1 minus 2g is equal to 2T1. This is our equation 2. Adding both equation 1 and 2, you got your answer A1 as minus 2g by 3. So why should you get the answer minus? Because I am letting that the direction of escalation is downward in block B, and if you so this is happened just because I've taken the wrong direction. If I take the direction of A downward, then I will got surely the positive sign here, so it will be not about avoiding. If you choose the wrong direction, then you will got a minus sign. So what is the answer? The answer is the escalation of a block A is 2z by 3, which is very clear. Now you have noticed you got your answer a block escalation of block has 2g by 3 in very short period of time, or you can see in very easily. But if you are trying to solve this question with the general method, you surely go in trouble, because in general method you have to use the constraint theorem where you can find the each each string length by differentiating it. Then after you can solve the question in general method. And if you want to know the general method, then please do comment in the comment section that please make a video on a general method of these questions. So I will upload the video in which I explain you the general method of solving this question. But here you can see the trick. How can the trick help us to solve this question very easily? Now I hope that you understand the trick and how to use the and how to apply the trick. So let's I give you the some questions for your practice. So the question number 1 is, what is the escalation of the block of mass 1 kg? So here you have a block of mass 1 kg and you have to find the escalation of this block. Now, question number 2 is the ratio of the escalation of the block of masses m1 and m2 as shown in the figure. So in this figure, you have to find the ratio of acceleration, that is a1 by of a2, a1 of a1 by a2. You have to find in these questions, and you have here is the figure. So if you want to practice more questions, then I will prefer you to buy a book, Physics: A Tricky Approach, written by the writer Deki Dharmatma. Here is the book pictures, where you can find this book at Amazon as well as www. You can http sribalajibooks.com. So you can check out this book for practice more questions on this trick. Now in the last, thanks for watching. Do not forget to like, share and subscribe. If you like this content and if you know the trick, then please do not forget to like, share and subscribe to my channel. Thank you once again.